Hey everybody, welcome to the final video on baby name fun with SSA data. So let's just pick up right where we left off. We had just gotten a plot of one name over time using a matplotlib command, just .plot. This next pane shows you how to get multiple plots at once on the same set of axes. So this code here, notice, I just ripped it straight from the previous cell. I just changed the name from Michael or David or whatever to Alan with the spelling. And then I've copied and pasted this right here. So these four lines here are like the same thing, except now I have a second name, and therefore I have a second data frame from national name with a second name, and then a second data frame here, and so on. So I've just tacked twos everywhere. So let me run this and show you what it does. It's going to plot the two name plots because you told it to, and whenever you have plot commands like this in the same cell, it's going to plot everything on the same set of axes. That's why you have one set of axes here with the two names. Now the blue curve in this plot here, the blue curve is always going to be what you told it to plot first. So you told it to plot Alan, or I told it to plot Alan with this spelling first, so that's the blue curve. The orange curve is what comes next. So here's the rise and fall of the name Alan over time of different spellings, right? So before 1942 or something, right? Alan like this was the more popular spelling of that name. But then for whatever reason in 1942, this other spelling of Alan overtook it and has stayed more popular ever since. Right here it looks like they almost collided again, and maybe the orange was going to dip below the blue. But for whatever reason, Alan with an AN has dominated Alan with an EN ever since 1942. So this is a pretty cute thing to be able to do, right? To be able to get multiple plots in the same set of axes. You can use this for all sorts of reasons. I mean, in the homework, I think you're going to get a plot over time of just the number of male babies and the number of female babies over time. That's interesting to look at on the same set of axes. This is total number of Allens this way, total number of Allens this way. Another fun thing to do, and you'll do this in the homework, is for a gender neutral name like Taylor or something, a Taylor there, a Taylor there, you can plot male Taylors by doing an M there versus female Taylors on the same set of axes, and that's also sort of fun to look at. So there are lots of reasons why you might want two plots on the same set of axes. So speaking of that, this next cell here, just to give you a flavor of how, I suppose, useful as this can be, I should say that I hesitate to show you this because what it's going to spit out is not particularly appealing, but it gives you an idea of the power of what you can do when you plot multiple things at once. So this code here is going to plot David, but by state. Okay, so it's going to get a plot for every state. So there'll be a plot of David's in Missouri over time, a plot of David's in Texas over time, and so on. Okay, so I go within the data frame and slice out that name David. And check out this for loop. This is why I like showing this to you, because this for loop is here. So, it's nice to see loops here. So now I say for x in data name state.unique. That's just saying go through all the states and don't repeat yourself. You want unique state names. Plot, so plt.plot, data name state equals x, right? So state equals Arkansas, state equals Alabama, and so on. This for loop's going to iterate through the state names and do the year, right? Same thing here. So year and then by number, right? So year is like the independent axis, the x-axis, and then number is like the vertical axis, the y-axis, and then it will plot it. I want to explain what these two lines are doing here in a second, but let me just show you what it spits out, okay? So again, I hesitate to show this to you because it's not super nice to look at. You'd have to do some work cleaning this up, but here are all Davids across all 50 states over the course of this data set. So there's a general sort of rise and fall, right? Although some states have this David bump and others apparently do not, right? There was like a little David bump in the 1980s when I was born. These two lines of code, by the way, just control the scale on the vertical axis. So notice the scale runs from 0 to 9,000. So I have a 0 here, and as long as you have a number bigger than 9,000 there, it'll have a 9,000 up here. And then they go by thousands, right? It goes from 0 to 1,000, 2,000, and so on. So anyway, this for loop here just has 51 different plots involved, right? This previous cell had only 2 plots, right? Name 1 and name 2. If you want a bunch of them, you can just set up a for loop to run through whatever you want it to run through, and every single time tell it to plot. And it'll put them all in the same set of axes to create, in this case, this jumbled mess. it still tells you something, I guess, right? But again, in general, you wouldn't want to like put this graph in your paper, but you get an idea of what you can do. Okay, so finally, I want to talk about proportionality here. Okay, so just to motivate this real quick, let me hop back up to the Michael curve or the David curve. Okay, so here's a David curve. So in terms of raw numbers, right, we can see the raw number of Davids went up and then went down. So there's a rise and fall. The question you might ask, though, is like this rise here, is this really as dramatic a rise as it looks? Because between the years 1910 and whatever this is, 55, right, between those years, the population overall was going up. There are just more babies being born, right? So if you just look at the percentage of Davids born, or like a per capita number, however you want to phrase it, right, a proportional number, this rise may not be so dramatic. Maybe the Davids are just keeping pace with population growth. Or maybe this rise actually is dramatic, you know. This tapering off here might even be more dramatic than it looks because you have a decline of Davids even as the number of babies is going up. So all I'm saying is this plot here is fun to look at, but maybe there's something we're missing by just looking at raw numbers because the population in 1910 is way different from the population in 2018. So let's just talk about how you get a proportional plot so that what's on the vertical axis here are not raw numbers, but percentages. The percentage of babies born named David in a given year. How would you do that? It takes a little bit of work, but it uses just commands we've seen before. Okay, so first, I'm going to create a data frame called data.jn for data just name. I'm going to go within the ungendered data. So again, if you want gendered information, you would just put an M or an F there, depending on what you want. As always, group by year, so go within a year, group by name, add up the numbers. Okay, so now check out this data frame. Data prop is going to be, I'm going to slice out just the year 1910, and I'll explain why in a second, but I'm going to slice just the beginning of the data. Then I'm going to create a total like this. Total is going to equal to data prop, add up all the numbers in the data frame. So what is this number total? It's the total number of babies born. Why is that? Well, because you're telling it, see this column right here? Python, right? You see that? Add up everything in that column. So if you add up all the numbers of babies, you get the total number of babies born in that year. So this is the total baby population. And now look at this command. This is familiar from a previous video. I'm going to create a new column, and I'm going to call it proportion. And what's that new column going to be? It's going to be the just name data frame, take the number column, and divide by the total. That's how you get the proportion of babies with that name, right? The number of babies in each entry in each cell, take that number and divide by the total. So let me show you what this data frame looks like after all this is done. It's just for the year 1910, right? So here's the year 1910, here's the name, here's the number. Those three columns are still there, but check it out, a new column because of this line here, which again should look familiar from a previous video. So what happened here? I took the number column, so I took that 111 number and divided by the total number of babies born to get this proportion of Aarons born in that year. Same thing for Abby, 28 over that, 31 over that, and so on. So notice all of these numbers are, of course, small. The percentage of Aarons born, even if Aaron is a popular name, right? Percentage of Aaron is going to be small. However, what you might care about is their relationship to each other, right? So this 0.000215 is way bigger than this 0.000054. So these proportions are going to be small for any name, but still, comparing like this number here to say this tiny number there is perhaps of some use, especially when you're plotting. So here's how you can create a data frame with proportion numbers for every single name. This, though, of course, was just for the year 1910. What I would like to do now is do this for every other year, right? Because if I'm going to plot the proportion of, say, Davids or whatever over time, I, of course, need to know the proportion of Davids in 1910, but also in every subsequent year. So how do I do that? This next frame does that. So again, it has this nice little for loop, right? So for year in years, right? Again, dot unique, just make sure I'm not repeating myself. So I'm just going to iterate over the years. So what are the years in this column? They're 1910 through 2018. Well, I've already accounted for 1910, so I'm not going to include that one, right? So if the year is not equal to 1910, then I'm going to create a new data frame called data M. I probably shouldn't reuse that name, but whatever. You can reuse it if you want to. We're at the end here. It's a new data frame, and it's going to be this just name and the year that you're thinking about now. Okay, right? So PD and then just name year. And then total is, again, going to be within that year, add up the numbers, and then within that year, do the same command we had before. Okay, so again, this looks kind of complicated here, but I'm just saying for whatever year you care about, do this thing that I've already done, right? Do this thing. Get the total number of babies and then divide each number entry by that total to get a proportion. So let me go back. And then notice this command here, this dot concat. We've seen that before up at the very top. That dot concat is kind of like an append. And to be honest with you, I don't really understand the difference between this and append. We're going to use append in the next video, or maybe the video after. So I'm not sure when you would use one versus the other. Somebody who really uses this in their work probably knows. But anyway, I'm just going to concatenate this or append this to the data I already have. So when this year is 1911, I do all of this for the year 1911 and then just add it to the 1910 data. So that just gets thrown onto the bottom here. I already have the 1910 data as like a starting point. And then year clicks up to 1912. And then again, I just take the total number of babies in 1912, create a proportion column and do the division to get a proportion and concatenate that and so on. It just keeps running, and it'll run through all the years. So let me run this. And then in the end here, I just want to show you what that looks like. Okay, so let me create a new cell real quick. So let me just show you data prop now. So it still starts in 1910, right? With whatever this proportion of errands. But now if I scroll, see the dot, and it goes all the way up to 2018. And it tells you that in 2018, the proportion of Zayas was 0.000002, right? Very few of them, right? So that for loop, right? That's what this for loop did. Our original data frame quit in 1910 because that's all we did. Now we just keep doing year by year so that we get all the way through 2018. So with that in mind, right now, let me show you. Here's the number of Abrahams over time. So notice, since there's a number column, I can plot by number. So here's just the number of Abrahams over time. So Abraham had a nice peak in the 1910s, tapered off, and then has been making somewhat of a comeback since the 1970s, although notice the top number here, 2,500. It's not the 80,000 popularity of Michael, right? Anyway, so that's what the raw number of Abrahams is doing, because I referenced the number column here. Well, what if you want to know the proportion of Abrahams over time, right? So this rise here, was this just sort of keeping pace with the number of babies born, or was this rise as dramatic as it looks? Let's look. Now I'm going to plot with proportion as the vertical axis, and let's watch. Yeah, so it almost just sort of kept pace, right? So notice this initial tapering off is actually kind of more dramatic when you look at proportions, right? This sort of valley is even worse than it looked here, right? But then this rise that we saw, this has the same slope as it goes up. So again, this picture here is more like a representative plot of what Abrahams are doing because it does a per capita number. It keeps sort of pace with the number of babies changing within each year. So anyway, this is kind of fun to do. So let's do a Michael here. That was the original name we looked at. So here's that Michael plot. Again, let's see if this rise is as dramatic as it looks and this tapering off is as dramatic as it looks. I'll put a Michael here and see. Yeah, okay, so notice the peak actually kind of lasts longer on some level, right? So this peak kind of falls off there and falls off again, right? This kind of doesn't do that, right? So even with fewer Michaels or something, it was still as a proportion, not falling off so much, I guess we're seeing from this picture. So again, if you care about proportionality, right, this is sort of more accurate or something, I guess, maybe a better representation of Michaels over time, because these points here along this curve are keeping track of the total number of babies born in a given year. So, okay, so at the end of this video, hopefully you have a taste now of the power of pandas combined with, say, other libraries like matplotlib, right, that you can get these nice little visualizations. Again, it's a miracle that we can do this, okay? When I was taking CS classes in 2002 or something, this was impossible, okay? It's so nice to have tools like this nowadays. I can just crunch all this data and just instantaneously spit this out. I mean, you could do this back in the day, right? You could do this back in the early 2000s, but it took forever, and it was not this nice, right? The code was just horrendous to spit out a graph like this. And again, it just took forever. Okay, so that's the end of the code I'm going to show you for the baby name data. So hopefully with this in your pocket, you can do the homework problems. I have one more data set I want to show you, and that will actually round out the course. So you only have, I don't know, at this point, maybe 2 videos left to look at some COVID-19 data. There are a few nice other things you can do with that data that weren't covered by this. But again, hopefully now with this real data set, you've seen the power of Python and pandas.